We're going to start off this experiment by preparing a stock solution of known concentrate. First, we've got to weigh out approximately 4 grams of copper sulfate. We're going to be using a top-loading balance. We first have to zero or tare once we put a weigh boat onto our balance. And then we slowly and carefully weigh out. And once we reached our desired mass, we're going to record how much copper sulfate we've weighed out. And then we're going to determine the mass of a clean, dry, empty volumetric flask that is 100 milliliters. Once we have our mass recorded, we're going to add the copper sulfate to the volumetric flask. And determine the mass again and record our balance reading. Once our copper sulfate has been weighed out and added to our volumetric flask, we're going to add approximately 75 milliliters of deionized water. Once we've added the water, we're going to swirl, and it takes several minutes until all of the copper sulfate is fully dissolved. Once fully dissolved, we're going to fill the volumetric flask slowly to the calibration mark. This is a white line on the volumetric flask. And then we're going to cap the flask, invert and swirl several times to ensure the solution is entirely mixed. We're going to label the stock solution S, so throughout the rest of the experiment, we know which flask contains our stock solution. The concentration of the stock solution may be calculated from the moles of copper sulfate in the volume of the solution. We're going to begin the construction of a calibration graph. This will be a plot of absorbent versus molarity. In order to do this, we're going to obtain 4 50 milliliter volumetric flasks and label A, B, C, and D. We will be using a volumetric pipette and pipetter to add our stock solution to each of the 4 flasks. We're going to add 5 milliliters of our stock solution to flask A, $10 milliliters to our volumetric flask B, $15 milliliters of stock solution to flask C, and finally 20 milliliters of stock solution to volumetric flask D. Using the same method of adding water to dilute each flask as we did with our original stock solution, we're going to add water until we reach the calibration mark. We're going to cover each flask with a cap and shake and invert to mix. we're going to measure and record the percent transmission of each solution, and from here we'll be able to calculate the molarity of each solution and calculate the absorbance using our equations. First, we have to adjust the wavelength setting to 625 nanometers. This is the analytical wavelength and the wavelength of maximum absorption for copper sulfate. We're going to obtain a plastic cuvette and fill it with DI water and place it into the sample holder. Using the spectrophotometer, we're going to measure the percent transmission and make sure we get 100% transmission. Once we've gotten our blank or our water percent transmission measured, we can measure our stock solution and our 4 prepared solutions. Now we're going to do a serial dilution by using the stock solution and performing 2 dilutions to obtain solutions of lower concentration. We're going to label 2 25 milliliter volumetric flasks X and Y. First, we're going to add 10 milliliters of the stock solution to flask X. We're going to dilute with DI water, cover, swirl, and invert to ensure mixing, just like we've done in the previous parts. We're then going to pipette 10 milliliters of the solution in the X into the volumetric flask labeled Y. We're going to dilute to the calibration mark with water, cover, and then swirl and invert to ensure mixing. Then we're going to measure the percent transmission of the solution in volumetric flask Y. The next to last thing we're going to do is directly prepare a solution of lower concentration. To do this, we're going to go back to our analytical balance and obtain 0.065 grams of copper sulfate. We're going to add our copper sulfate that we just weighed to a clean 10 milliliter volumetric flask labeled Z. Add about 7 milliliters of DI water and swirl until all of the copper sulfate is dissolved. We're going to finish filling the volumetric flask to the calibration mark with water, swirl and invert to ensure a thorough mixing. Then we're going to measure the percent transmission of our solution in volumetric flasks X, Y, and Z. Lastly, we're going to obtain an unknown solution. Our unknown is labeled unknown E. We're going to measure the percent transmission and determine the molarity of the solution using the equation obtained from our calibration graph we created earlier. This was the demonstration of molarity, dilutions, and preparing solutions. Thank you for watching.